Okay, everybody, welcome to week 6 of Violent Python. This week, we're going to kind of cover some basics of extracting some evidence from the internet. There's a few scripts to go through to kind of get you started and some samples that you can go through on your own to kind of walk through those. And that's what we're going to be covering tonight. I've provided some links here for the libraries so that you can go read the docs on the libraries that we're going to use. I'm going to talk about those, but there's some basics here. The two libraries we're going to be using is Requests and Beautiful Soup. Both of those obviously are installed in the VLE for you. So you don't have to install anything. Both of those are third-party libraries that we're going to be doing. But what I'm going to do first, I'm going to do a quick walkthrough of the week 5 solution so that you guys have access to that. And I will post that for you tomorrow, just in case you want to actually walk through that yourself. What I did for the week 5 solution was I combined both assignments together, the email URLs and words, just so I can walk through them easier for you. And I'll give you the solution for that, and it'll cover both assignments, just so you know. So again, in this case, I'm bringing in just a few libraries here, the regular expression library, of course, that we're using to be able to find specific patterns, in this case, emails, URLs, and words of a specific size. So I'm going to do this with the dictionaries in order to be able to keep a dictionary of the emails, URLs, and words that we found. Hold on a second. Excuse me. Sorry, my heater makes a lot of noise, so I wanted to turn that off. Anyway, I'm going to create 3 empty dictionaries here for you: email, a URL, and word. And I'm going to process the mem.raw file, but I'm going to process it in chunks. And I've decided to process it in 1 megabyte chunks since my system will easily handle, 1 megabyte chunks of data coming from the raw file. Also, in this example that I'm going to give you, I created some overlap data so that I can actually take data that was in the previous chunk and prepend it to the new chunk so that we can handle the overlap. It's pretty simple to do that, but I'm going to walk through that process. So why don't I actually, instead of walking through the code that way, let me actually step through it for you so you can kind of see it in action like I normally do. So anyway, again, just loading the libraries. And then I'm going to compile the 3 patterns. So basically we have, again, the email, the URL, and the word pattern that we've chosen. I'm going to initialize the 3 dictionaries to be empty. It's always nice to do those kinds of things at the top of your script, just to get them out of the way so you don't get confused and actually get them involved in the loop and they get changed and whatever. The same thing with the pseudo constant like chunk size. And then I'm going to keep track of the number of chunks. And then I'm also going to initialize the overlap data to be empty, because the first time through the loop, I don't have anything to overlap because the chunk is the chunk, right? So what I'm going to do next is I'm going to open the mem.raw file. I'm calling it binary file is the object I'm going to use. And I'm going to go ahead and read in the first chunk. If I have a chunk, in other words, if there's any data, in the chunk, and obviously there is, it's a 1 megabyte chunk that we just read, I'm going to basically prepend that overlap data, which right now is empty, to the chunk. You'll see how I use that at the end. Then I'm going to actually process the emails, the URLs, and the words using the patterns. So basically, I'm going to find all the emails, all the URLs, and all the words that was in the first megabyte of that mem.raw file. And then for each email, we do this for each of the types. So I'm going to create 3 loops here, 1 for email, 1 for URLs, and 1 for words. So for the emails, there weren't any. I did for emails and emails. You could tell in the emails, there weren't any. Let's see if there was any URLs. There wasn't. Were there any words? Yeah, there's going to be words. So basically for each word, to kind of give them the broadest match, I'm going to create a lowercase version of that. I'm going to see if the words in the dictionary, you've seen this code a million times. If it's in the dictionary, I'm going to add 1 to it. It's not in the dictionary yet, so I'm going to add that particular word. If I go back and look at the word dictionary, the first word that we found was MS-DOS. Not really a word, but it's a string that met the criteria. So then I'm going to process all the words. I'm going to set a breakpoint down here so I don't have to step through all of the words. I could go back and look at it after I've done that. And now I got a whole bunch of words that have occurred more than one or more times within that particular chunk. Now I'm going to increase the chunk count by 1, right? And I'm going to get the overlap data. So I'm going to take that chunk that I have, and I'm going to get, in this case, I'm going to get the last 60 bytes of that chunk. So I'm using chunk bracket minus 60 colon. So 60 bytes from the end to the end of the chunk. I'm going to put in overlap data. Then I'm going to go ahead and print out the chunk count. I processed 1. Now, the second time that I go through this, I'm going to read the second chunk of data, which is going to be another megabyte. But this time, I'm going to take that overlap data and I'm going to prepend it to the chunk. So now I've actually considered the data that was at the end of the previous chunk. I've added it to the current chunk. Everything else works the same. So based on that, let me at least set a breakpoint here so you can show you that we actually get an email and a URL, see how those are processed. So if I go here, so now I got an email. So in this case, I found an email address. I'm going to make it all lowercase. I'm going to see if it's in the dictionary. It's not. So I'm going to add it to the dictionary. And now my email dictionary has something in it. I'll clear that breakpoint and say go. Oh, now we got a URL. So that was the first URL that we found. Again, same thing as before. I'm going to check to see if it's in the dictionary. Obviously it's not, because we've not got one of those before. And now I'm going to update that, and I can look at my URL dictionary, and it's got 1 entry in it. Key is the URL, and the number of times it occurred is once. So you've seen this code multiple times, so I won't bore you with all of that. So now I'm going to go through all the chunks, and then I'm going to print out my results. So basically this is going to run till we complete. Make sure I don't have any breakpoints set here. So I could run through this, so we can run through the whole mem.raw file. So I'm going to continue. So now we're going to process each block, each chunk in this particular case. So this goes pretty quick because I'm processing 1 megabyte at a time, and I'm applying that regular expression. So you can kind of see how quickly this regular expression can extract the data that we want. That's why we use them, because it can find those patterns relatively quickly for us and give us all of those occurrences of the patterns that we have. So once I've done that, basically what I'm going to do is I'm going to say that I want to print out here, create an email table, which is occurrences and email address. So I'm going to create the table here once, and then I'm going to loop through each of the values in the table, and I'm going to add those to the rows. When I'm done, I'm going to do the same thing for the URLs, and then I'm going to do the same thing for the word tables. So when I get down here, I'll set a breakpoint here now. Now that I've created the URL, the email URL and word table, once I've processed all those, this does take a second to get down to printing them out. So now we're going to print out the sorted email table. So these are all the emails we have. I wanted to sort it by occurrences. I want the highest number of occurrences first. So I use the reverse sort, and then I print those out. And so now we can look at the, we can look at, I get my cursor in the right place here. We can look at the email table, and we can see they're sorted. So the email address that occurred most often is at the top of the list, and the ones that occurred the least are at the bottom of the list. I can do the same thing now for the URLs, and I'm going to print the URL table same way. And now I have all of the URLs that we found, again, in occurrence order. And then we're going to do the same thing for the word table. This takes a minute because there's a lot of words, that were found throughout of that met that pattern that we found. They're not words that met the pattern that we're looking for, which was A to Z and 5 to 12 characters. So it's going to take a second to process all those, because there was a lot of those compared to the emails and the URLs that we found. So that's the solution. Like I said, I combined the two solutions together and also included the code in order to be able to handle the overlap so we don't miss anything. And then we can, I'll post this solution for you tomorrow. So if you had any difficulty with the assignment, you can go back and take a look at the solution and do that. So again, you can tell that these all don't look like words. I have a solution for that, but I'm not going to go over it. I can't even go back to the top because there were so many of the words. They don't fit in the output display. Any questions on that quick overview of the solution for week 5? Like I said, I will post that for you tomorrow so that you can play around with it, step through it if you had any issues. But do you have any questions? If you will, I'd be happy to answer them.
Yes, I had a question.
Sure.
In the overlap, was there a magic reason you selected 60, or was that just an arbitrary number? Or I mean, I get the chunk size obviously corresponds to a megabyte. I didn't know if the 60 corresponded to something as well.
Well, we know a couple of things, right? One of the reasons I chose that chunk size is one is that we know that the largest word that we're going to basically handle is 12 characters, right? 5 to 12. Email addresses can be sometimes long. They could be 30, 40 characters, and URLs can even be longer. So I just basically arbitrarily picked a number that would cover that overlap if it was a URL or an email address that was there. You could tweak that and see if you get more results. When you get the result, when you get the script, you could play around with that number and make it 80 or 40 and see how the results differ, especially in relationship to the emails or the URLs. It's not going to differ for the words, but it might differ. If you choose different values, you'll see a difference in the result that you get. You can even make the overlap like 0, right? Or 1 or something like that, and kind of see the difference in the output that you're going to get from the emails and URLs, because you will skip some if you don't have the overlap, you will skip some of the values. That makes sense?
Yes, thank you.
You're welcome. Any other questions? Okay. Good question. Let's go back to the brief and get into what we're going to do this week. And so when we're going to extract evidence from the internet, specifically web pages, for example, that's what we're going to focus on this week. Obviously, the mining of that information has become pretty commonplace. And there are some restrictions in doing this, and that's why you guys are going to apply it to Cyberopolis, not to the real internet. Let me say that again. You're going to apply this to Cyberopolis. So you're going to do this week's assignment within the VLE. You are not going to basically apply this to websites that are on the real internet. A couple of reasons. If you run your script on the real internet, and let's say you applied it to some website out there that was paying attention to such things, they're going to block you and then even ban you and even potentially blacklist you. Okay, so whenever we do this for real on the internet, we use autonomizers and that kind of stuff in order to be able to hide who we are so they can't blacklist us. But we're going to do this within the confines of Cyberopolis, so you won't have any problems if you stay there. Just kind of a word of caution. The other word of caution is if you ever decide to do this on the real internet and you're doing it on, let's say, hostile sites, potentially gang or terrorists or worse sites that are out there, you are going to put yourself at risk personally, because they can attribute and track you if you're not using the appropriate proxies in order to be able to do that. So don't do that unless you have specific techniques that are going to protect your identity on the internet. So let me say this again. Do not do this on the internet for real, number one, unless you really, really know what you're doing and have protections in place. And number two, for our assignment, you're only going to apply this to Cyberopolis. Based on that, there are a couple of Python standard libraries and third-party libraries that will assist us in this kind of acquisition process. The first is something called the requests library. The request library allows us to basically make a request to a specific page. In this case, I'm just going to python.org, which is a safe site to go to. And I'm just going to get the page, and I want to get the page text. So that's what requests does for us. It returns an object, and one of the properties of that object is going to be text. So if I come back to my Python environment, and bring up, I think it's just the EXP14, I think is the one. Yeah. So this is that code that you just saw. And so we can actually step through this script just to kind of give you a feel. And you should be doing this on your own too, okay? But I just want to make sure that you know how to do this. So I'm going to import the requests library, again, which is already installed for you within the VLE. I'm going to ask requests to get that particular page on the internet, which is basically the python.org website. And it's the homepage. And then I'm going to print based on this. I'm just going to print out what is the type of the variable page. You might be interested in that. And okay, it's a request models response. It's a class. There's an object that gets returned by the request library. And one of the methods, one of the properties, actually, not even a method, one of the properties associated with that is page.text. And I can print that. So I can basically say page.text, which is one of the properties of the object. And now I can actually print out that HTML source code that was associated with that particular page at python.org. Okay, so that's the simplest thing we can do. And obviously there's quite a bit to that particular web page, right? There's quite a bit of stuff there that basically comes down from that particular web page, but we have it all now that we can actually look at it, and I'll end the script. So the first library, like I said, you're going to play with is the request library in order to be able to kind of just get the contents of a web page. So, you know, based on that, some abbreviated results that you just saw. So now I'm going to walk through the second library that we're going to talk about, which is Beautiful Soup. And you're going to do this. I'm just going to kind of demo it for you. I'm not going to step through it for you. I'm going to demo it for you. And then you're going to actually take exp14.py, which is in D2L for you, and you're going to use it, you know, and against the websites that you are supposed to be applying that to. So again, if I bring up exp15, and again, I'm going to apply it to python.org again, which is one of the safe places that you can do here on the internet. And let's see what we get. So in this case, I got the page just like I did before, but now I'm going to pass the page text to Beautiful Soup. Okay, I've imported the Beautiful Soup library. I'm going to get the page text and I'm going to pass it to that particular Beautiful Soup module, basically function. And I'm going to basically say, hey, I want you to parse the HTML from the page. And so then I'm going to print out that page text. And then I'm going to print out the title of that page. You can kind of see how this works. I'll do a little bit of this for you before I just run it. I can. So we've loaded the Beautiful Soup library, right? I'm going to go get that same page that we just got, which was that that page from python.org. And now I'm going to basically get the soup, you know, basically, which is going to take that page text and Beautiful Soup is now going to, instead of just looking at the text, it's going to parse the HTML for us. And so again, I can print the page text like I did before. I can now use soup, which is a new object, right? And it has some really cool capabilities. Again, a property of that is the title. And it's going to come back and tell me what the title was of that HTML page that I just extracted from python.org. And also it's going to print it out and say, oh, it was welcome to python.org. That was what the title of that particular page is. If you go to the internet and go to python.org, you look at the title of that page and that's what it will be. Next thing I'm going to do is I want to collect all the images, the image links, I'm sorry, and then all of the links to that. And I can print out and type images. So now let's see what happens if I just run this, because you're going to actually do this yourself. If I just say go from here, it did a whole bunch of things for me, right? So I originally came back and I printed out that original HTML that we did before, which is the text. And then it printed out welcome to python.org. And then it's going to give me all of the links that were associated on that particular page. It's going to show me all the references, all the links that were on that particular page to other pages. We're not going there. We're just getting the links to know what they were. And you can see that there are a lot of them, again, that are on that particular page. And then it's also going to print out the images that were there as well. So if there was any images that were on that page, it's going to basically show those. You're going to walk through that yourself and see how that actually works in order to be able to do that. So again, your kind of assignment here is to use that EXP14 in order to be able to see how it can actually, you can scroll through the results and see what those links are that Beautiful Soup has gotten for us. And just kind of showing you what that looks like. And then we're going to, EXP15 is going to actually do one more thing for us. And I'll just go through here. And in this particular one, it's going to not only find any of the images that are on there, but it's also going to extract them and write them to a file. So not only is it going to find the pointer, in other words, the link to the particular image, it's also going to download that particular image and write it out to a file. So if in this case, I run this particular script, which you can then step through, I'm going to say go. Make sure I got the right one. And now it says script is complete, and it only found one image on that particular page, which was Python logo.png. If I go back to make sure I'm in the right place, I got to go to week 6 scripts. And you can see that I wrote the Python logo out to a file, and that extracted the actual file. So now we have a way not only to collect the page text, we have a way to collect all of the links that are associated with the page. We can identify all of the image links that are image related to the page. And now we can actually extract, okay, all of the actual images and store them in a file. So now we've gotten all of the pieces that we're generally interested in. There's more, but generally those are the things we want. I want to know all the links. I want to know all the links to images, and I want to download the images that were on that particular page. And that's what those 3 starter scripts do for you, giving you that. One gets the text, the next one gets the text links to the pages and links to the images, and the third one shows you how to extract the actual image itself and then actually save it out to a file. So that's what those samples do for you. So going back to this, and then the last one is EXP16, which extracts, again, the images and stores them in a folder. So what you're going to do, let me go to here, go to content, and week 6. You have one assignment this week, and that is going to be to use the EXP 14, 15, and 16 starter scripts that I've provided you. And you're going to extract information from the CASL website that is in Cyberopolis. So you're going to run all of your scripts this week from Cyberopolis. And what you're going to do is you're going to extract the page title, and you're going to extract the URL links and the images found on the page. Okay, so you're going to basically do that for the CASL website that is on within Cyberopolis that you can access from the VLE. So as long as your script is running for the VLE, you can access that particular website. So that's the website you're going to use as your target. Okay, so your first assignment this week is to study and experiment with EXP 14, 15, and 16 to make sure that you understand how those work, right? So you're going to kind of step through that with Wing IDE, make sure that you understand how those work, and then you're going to go ahead and tackle the assignment. Remember, when you're tackling these assignments and going through the sample scripts and watching the video or the replay of the video, God, I hope I recorded that. I bet I didn't. Nope, I did. Whew. Sometimes I forget to do that. Anyway, Elizabeth's supposed to be watching to make sure I did that. Anyway, one of the things, the way to approach the assignments that I want to make sure that you guys are thinking about is review the video and the walkthroughs that I've given you, and then go through the sample or the starter scripts that I'm giving you, and then try to tackle the assignment. Once you've done all of that, then go take the quiz. Okay. So, all of those pieces, and then certainly if there were any other resources, chapter 5 in the Black Hat Python book, whatever, make sure you do all of those things before you tackle the quiz. Then the quiz is going to be a snap. But a lot of folks that I see, they start this and the first thing they go off and try to take the quiz, and they haven't, reviewed in detail the lecture. They haven't gone through the starter scripts. They haven't tried to tackle the assignment. They haven't done the reading, and then they don't do well on the quiz, and they're not happy. But you've got to kind of take this in that order. Focus on everything and do the quiz last, and you won't have any issues, I'm certain. Any questions regarding this week? This is pretty straightforward. It may look complicated right now, but if you do what I say and walk through those individual starter scripts and understand how they operate, do this within the VLE. One of the tricks is that when you're in the VLE, you can go to Cyberopolis, you can bring up the browser that's there and take a look at the website that you're going to actually scrape from, right? Just see what it looks like before you start, trying to extract data from it. Then get the text, then get the links, then get the images, and kind of walk through that process in the same way that we're doing here. Okay. Any questions? You guys still there? Anybody?
Yes. Still here.
Okay, thanks. Just wanted to make sure I didn't go offline here for some reason. So yeah, this is fun. Take a look at this over the next couple of days, and then you can bring any questions that you might have to the Python tutoring session on Saturday. And if you don't get to it till the weekend, then make sure you bring some of the questions to the office hour on Monday. And, we can try to dissect any of those issues you might be having, from that perspective. So, kind of take this in chunks so that you can then ask some questions or post some questions to the discussion thread. And then we'll take a look at those and, either create another video or, answer the question right there, or answer the question during the tutoring session or during the office hour, whatever's more appropriate. So kind of this is going to take a little bit of time to actually go through this. So kind of take it one step at a time. And I think you'll have some fun with this. Hey, Elizabeth, I know you're on the line. Thank you for helping out here. Did you have any questions that came across your desk over the last couple of days that need addressing at this point?
Not really. I believe you covered it when you were doing the solution. It was just more with the pretty table.
Okay. All right, good. Yeah. So the overlap and how I created the pretty table. And like I said, I cheated a little in my solution in that I only provided one solution, but it does everything that the two solutions that you were going to provide do, but just so that you have something that you can walk through. And I will post that tomorrow so that you have access to that. If you detect any problems, you can step through mine. So yeah, thanks for reminding me of that. I will make sure I post that in the morning. And I have enabled, let me make sure. Yeah, I enabled the week 6 and the quiz and the assignment and all of the starter scripts for you. So they're all there ready to go. So start there, start experimenting with this. There's some good references in the book. There's some good references that were in the briefing. If you recall at the beginning of the briefing, I had provided some links to, thought I did, yeah, to Beautiful Soup and a couple of examples. And then there's a beginner's guide for using Beautiful Soup for web scraping. So if you want a different reference than what I've given you or the sample, the starter scripts that I provided, there's a few links there for you where you could start. Okay. All right. If there's nothing else, I'm going to give you like 30 minutes of your life back so you can get started on this. So have a good rest of the week. Hope to see you on Saturday and Monday. Have a good rest of the week and weekend, and we'll talk to y'all soon.
Thanks a lot. Bye, everyone.
Take care, everybody. Bye-bye.